to the weather classroom.
The atmosphere. We live at the bottom of it. We swim through it every day. We even breathe it 16 times a minute, and most of the time, we don't think about it or even know it's there. And by the way, where did it come from anyway? You'd think it's been there forever, but everything's got a beginning, and the atmosphere is no different. Our friend Dr. Jim St. John at the Georgia Institute of Technology gave us a little history lesson on our own sea of air.
Scientists generally believe that our solar system began as a large cloud of gas and dust in the Milky Way galaxy. Gravity caused this cloud to collapse upon itself. Most of the material went into the sun, and the rest became the planets. Now, when the Earth was formed, most of the heavier material became the Earth and the oceans, but there was an initial atmosphere which was composed of carbon dioxide and nitrogen. Now, when life forms first began to appear on the Earth, they began producing oxygen through photosynthesis. Now, this was originally suppressed by a reaction of oxygen with volcanic gases. However, over time, much of the material within the Earth began to oxidize, and the volcanoes began emitting less hydrogen and carbon monoxide, and this allowed the oxygen to build up to its current levels, where it exists in an equilibrium, where it is destroyed by volcanic gases, the weathering of rocks, and respiration, and is produced by photosynthesis. And it's been that way for about 2 billion years now.
Okay, now my favorite expert, Colin Marquis, is going to give us the rundown on the layers of the atmosphere. He is so smart.
Sarah, the atmosphere is actually really thin. If the Earth were the size of a beach ball, the atmosphere would only be about the thickness of a piece of paper. The lower part of the atmosphere, the lowest part of the atmosphere, is called the troposphere. And that's where all the weather that we're familiar with takes place. Temperature tends to decrease as we head upward through the troposphere. Next comes the stratosphere. And the stratosphere is where we find the protective ozone layer. Temperature increases as we head upward through the stratosphere. Above the stratosphere is the mesosphere. In the mesosphere, we find the coldest air in all of the atmosphere. The temperature tends to decrease with increasing height. Above the mesosphere is the thermosphere. Temperature turns around once again and actually increases with height. And this is the layer of the atmosphere where most of the meteors tend to burn up. And then finally we have the exosphere, and that's where the atmosphere is getting so thin, it's literally merging with outer space. And that's about it.
See how smart he is? Time to get back to Earth, though, and the well-traveled Jason.
We're at the Furnace Creek Inn in Death Valley, California. It's a great day, so we're going to take a little field trip. Got the top down, got the sunscreen on. So let's go get the lowdown on this air pressure thing.
In order to understand air pressure, we have to understand the term pressure. We hear the term pressure all the time, and we know that pressure is a force or some type of push. And the molecules that make up our atmosphere, or the sea of air that we live in, actually have weight. And this weight exerts a force down on the earth, the ocean, the land, the trees, houses, even you and me. It exerts this downward force, and that is what air pressure is. It's this force that's exerted on us by the weight of these molecules. Air pressure is a very key component to the weather that we see every day, no matter where you live. And when we hear the term air pressure, usually meteorologists on TV, you hear them talk about low and high pressure. These are pressures that affect what we see. Usually around a low pressure area, we'll see different weather like thunderstorms or snowstorms, those kind of things. But around high pressure is kind of good because it will be sunny, it will not be as cloudy in most instances. Most of us live right around sea level, and we experience air pressure because there are a large number of molecules that are above us that are exerting a pressure or a force down on top of us. But as we go up in the atmosphere, the pressure decreases because the number of molecules also decreases. If we were to jump in our car and drive into the mountains or climb a mountain, our body would notice this decrease in pressure, and our bodies would try to equalize our internal pressure with the external pressure. And what we might feel is kind of like a popping in the ear or something like that. At the same time, if we're climbing a mountain, we need oxygen to do that. And at a higher elevation, there's lower pressure, a fewer number of molecules, and a fewer number of oxygen molecules. Therefore, our body would realize this very quickly. Our breaths would get faster and deeper, and we would really need to slow down.
Here we are, weather fans, the lowest point in the Western Hemisphere, Badwater Death Valley, 282 feet below sea level. Now, we're going to go for a ride with our barometer here, which measures air pressure. And this bag of chips and this bottle of water up into these mountains and see what happens when we go up into a sea of air. Come on. Okay, sea level, ground zero for altitude. And our barometer reads 29.76 inches of mercury. Let's keep going up and see what happens. Check this out. As we go up the mountain, the altitude starts to increase. Look at what the barometer's doing. It's getting lower. Let's keep going to the top. Here we are at the top of the mountain. The altitude is 5,475 feet. Our barometer reached 24.26. Moral to the story, as the altitude increases, the air pressure decreases. Let's hop back in the car and see what happened to my bag of chips and bottle of water. The air pressure inside the bag or the bottle haven't changed while it's gone down outside. So, they've blown up like balloons. Now, when your ears pop while you're going up a mountain road, for instance, that's your body's way of adjusting to the drop in air pressure. But when you're on a plane, you're really high in the atmosphere, right? So do you think the air pressure drops drastically? Well, let's see. Oh, there you are. Okay, we're flying at about 35,000 feet above the ground. Air pressure should have dropped like a rock, right? Well, let's see what Mr. Barometer has to say about that. Nope. Pressure is about the same as if we were on maybe a small mountain. What's up with that? Well, the plane cabin is pressurized. They pump air in to keep the air pressure up, so we all stay comfy. But the real mystery is, how did they get the camera outside the plane?
Don't go away. The Weather Classroom will be right back.